A very warm welcome to all my friends and followers. Today we are going to discuss about support vector machines. Support vector machines are non-probabilistic binary classifiers. So let me write over here non-probabilistic. What does this mean? Non-probabilistic means that the support vector machines do not make any assumptions on the probability distributions of the independent variables, unlike naive-Bayes algorithm. Like naive-Bayes algorithm makes a lot of assumptions on the probability distributions of independent variables, that the distribution has to be normal in shape, and also the variables have to be independent of each other. Independent variables have to be independent of each other, not related to each other. But support vector machines do not make any such assumptions on the independent variables. Also, support vector machines are binary classifier, which basically means that it was very good algorithm to classify the dependent variable into two categories. Example, classification of emails into spam or ham, classification of fruits into apples and oranges. But suppose there is a third category available. For example, let's say there are bananas also in my fruits, apples, oranges and bananas. Then support vector machines cannot be used. So it's a binary classifier. Okay, now let us first understand in two-dimensional feature space about how support vector machines algorithm works. Okay, here is my two-dimensional feature space, which basically means that I have got two attributes, x1 and x2. I have to classify into green and peach. These are the two categories that I need to classify in. SVM will try to find a line that makes a clear separation between the two clusters. So it's a linear classifier. So SVM is a linear classifier. It is trying to find a line that will make a clear separation between the two clusters. What about a three-dimensional feature space? In a three-dimensional feature space, SVM will try to find a two-dimensional hyperplane which makes a clear separation between the two clusters. Now let us understand what exactly is a hyperplane. A hyperplane in an n-dimensional feature space, a hyperplane is a geometric shape of n-1 dimensions. So in this three-dimensional feature space, the hyperplane is a geometrical shape of two dimensions, right? These are the two dimensions. In case of a two-dimensional feature space, n-1 dimensions will mean one dimension. So it's a line. A line, the hyperplane will be the line in case of a two-dimensional feature space. In case of a three-dimensional feature space, it will be a two-dimensional plane with zero thickness. In case of n-dimensional feature space, a hyperplane will be a shape of n-1 dimensions. Okay, now the next question comes. So it's a linear class. Hyperplane is linear. This is a linear hyperplane that we are trying to find to categorize our two categories. Okay. Now coming on to the next question. Now when there are so many, in order to categorize these points into green and peach, so many hyperplanes are possible, right? Which amongst them is the one that our model will choose? Each line will have different equation, right? Which is the one that our SVM will choose, our model will choose? Okay, so coming on to the answer of this question. The best hyperplane is the one that maximizes the sum of distances of the nearest points on either side of the plane. So what we'll do is, let us assume this is the line. Let us assume this line. So this line, let us assume, has an equation. So this is not nice. Let's use a different color. Let's say, purple color. Okay. Now let's assume the line over here has the equation this line has an equation of ax1 plus bx2 plus c equal to 0. Okay, so this is my lines equation. Now if I try to substitute, I try to find out the distance of this point from this line. How do I find out the distance of this point from this line? Suppose the coordinates of this point are x1 1 comma x2 1. Okay, these are the coordinates of my point. I want to find out this distance from this line. Then this distance will be equal to, I'll simply substitute my points in place of x1 and x2. Okay, a x11 plus b x21 plus c divided by under root of a square plus b square. Okay, so this distance will be equal to this part. So we'll try to find out the distance of all the near points, nearest points, close points, and whichever closest points, and whichever and we'll try to find out the sum of the distances of the nearest points on both the sides of the plane, and we'll try to maximize that distance and arrive at the best hyperplane, which will mark a clear separation between the points, as well as the distance with these nearest points is the maximum. These nearest points are called as support vectors, as they support my hyperplane. So let me explain this. So how to find out this becomes a how to find out this line, this becomes an optimization problem, wherein there is a clear objective function and there is a clear constraint. The objective function is to maximize the sum of distances of the nearest points on either side of the plane, and the constraint is that still we have to make sure that the two clusters are absolutely separate. So this is a standard quadratic programming problem which can be easily solved, and a maximum margin hyperplane can be obtained. So this term you need to remember, maximum margin hyperplane. Maximum margin hyperplane. Let me show this to you, maximum margin hyperplane. So this line was found out as the best fit which could maximize the distances with the nearest points, as well as create a clear separation between the two clusters. So this is the maximum margin hyperplane in a two-dimensional space. Okay, and these nearest points are called as support vectors because they give support to my maximum margin hyperplane. Just to explain you the intuition behind the support vectors, let us assume the problem in apples and oranges. In apples category, SVM will try to find an orange color apple which looks like an orange. Okay, and in orange category, SVM will try to look for an orange which is green in color and which looks like an apple. So these are the support vectors, which are very near to the other category. Okay, now we have understood this. So SVM, what it will do is that it will find out the coordinates of these points after finding the equation of the line, after finding the maximum margin hyperplane. It will simply, for example, suppose it has to classify a point here. Let's say this point needs to be classified, let us assume. Okay, then it will try to find out the coordinate. It will take the coordinates of this point. Let's say the coordinates are x11 and x21. Okay, it will find the maximum margin hyperplane. Maximum margin hyperplane will have some equation. Let us say the equation is ax1 plus bx2 is equal to c. Okay, this what we'll do is that we'll try to find out the value of ax11 plus bx21. That is, we'll substitute these points over here, and minus c. Okay, so if this value is greater than 0, then we'll qualify it as red in this color, red color. And if it is less than 0, then it is classified as the other category. So this is category 1, let's say, this is category 2. So if it is greater than 0, then it will be classified as 1, and if it is less than 0, then it will be classified as 2. Or if we want to separate it as let's say in case of emails problem, in order to classify them as spam or ham, if it is greater than 0, then it will be classified as spam. If it is less than 0, then this will be classified as ham. In case of a 3-dimensional space, here also we'll try to find out the distances with each of the each of the hyperplanes possible, and find out the maximum margin hyperplane. Once we found out the maximum margin hyperplane, in order to classify a new point, categorize a new point into spam or ham, let's say, what we'll do, let's say this is my point. We'll find out the coordinates of this point. The coordinates will be, let's say, x11, x21, x31. Okay. The equation of the plane will be something like ax1 plus bx2 plus cx3 is equal to d, let's say. Okay. So let me write the coordinates. x11 x21 and x31. These are the coordinates of my point. The equation of the hyperplane, let's say, is ax1 plus bx2 plus cx3 equal to d. Okay, so we'll substitute the coordinates in this and find out the value of fx. Minus d. Okay, we'll find out the value. If this is greater than 0, then that means it will be classified as purple, and if it is less than 0, it will be classified as pink. So I hope this is linear support vector machines are very clear to us. The next step, guys, in my next video, I am going to cover how support vector machines are used for non-linear classification. Since we already told you that support vector machines are linear classifiers and not non-linear classifiers, but they can still be used for non-linear classification problems. So let's cover that in the next video. Thank you, guys. Bye. Please like my video, and please share the video, and please subscribe to my channel. Thank you. Bye.